My name is Hayes Van Tassel, and I'd like to take a few minutes to talk about MPLS versus Metro Ethernet, a couple of networking products that are available to business consumers that will connect their locations to each other and the internet, whichever is needed. Some benefits of both of these services include that they're both highly compatible with existing protocols and networking equipment that is probably deployed out there in the wild. They both offer low latency and guaranteed bandwidth. They're both highly scalable, and they both offer secure and sometimes even private connections. And their connectivity is delivered with an SLA and an assured quality of service. And they both carry VoIP and IP traffic. So which one's better? Let's take a few minutes to talk about MPLS. MPLS stands for Multi-Protocol Label Switching. The multi-protocol means it's adaptable or highly compatible with a lot of the different layer 2 um, transmission standards there are out there, such as frame relay, ATM, SONET, DWDM. MPLS is compatible with just about all of them, including Ethernet. Now, what is MPLS? MPLS is a layer 2.5 routing technique that injects a shortened label just between the frame layer 2 and packet layer 3 headers. MPLS uses these labels instead of IP address information to build routing and forwarding tables. And since the routers only need to inspect the label, this significantly reduces device overhead and the time it takes to deliver a packet. And it's typically sold as a package with an IP VPN service. How does MPLS work? Some of the rules for MPLS, the process for MPLS is that each router will assign a label and based on its IP address, and then it shares that label with its neighboring routers. And once those routers receive their sort of shared labels from their neighbors, they build routing and forwarding tables based on those labels, and then they route using those labels. And this overall, since the 3 to 4 digit labels are usually shorter than or they're always shorter than an IP address, the overhead on the devices that they have to traverse is significantly reduced. Down here, you can see a Wireshark capture of an MPLS packet. And we have at the very top, we have a layer 2 frame. And then just below that, we have another segment indicating that we're using an Ethernet frame. And then just between the Ethernet frame and the IP header, we have an MPLS label. This one is 12701, which when routers use shortened labels like this rather than 32-bit IP addresses, they are able to save a lot of power, time to route, and a lot of different things like that. Metro Ethernet stands for Metropolitan Ethernet. Metro Ethernet is a carrier-grade expansion to the IEEE 802.3 Ethernet standard that has been adapted for internet service providers to deliver high-bandwidth MAN and WAN connections. It uses the same layer 2 processes to encapsulate packets within the frames, and it uses the same physical layer equipment standards as 802.3. Just the equipment's a lot more beefed up and industrialized to fit carrier-sized packet delivery. Standard speeds for Metro Ethernet range from 100 megabits to 10 gigabits per second, although you can go higher than that. Typically what we'll do, I work in telecom, and typically what we'll do is concatenate multiple 10 or 40 gig circuits to make really big pipes. And Ethernet can be, Metro E can be transported over SONET, SDH, MPLS, or DWDM OTN. It's generally limited to metro regions for now and can be used to privately interconnect locations just to connect to your internet or both. This is a basic Ethernet model. How does Metro Ethernet work? The service provider installs an Ethernet switch near the demarc point. Their customer equipment connects to an allocated switch port known as a user network interface, or a UNI port. Two or more UNIs are then associated to create an EVC, and configuring an EVC allows traffic to flow between its associated UNIs and prefers data transfer to subscribers not part of that EVC. There are two types of Metro E topologies. There's E-line and E-LAN. E-line is basically just a point-to-point connection that bounces from, if you want to connect two sites, you send a packet from one site to the UNI port it's connected to, and then it crosses over the EVC out the UNI port and out to your other site, and that's sort of a point-to-point connection. Multi-point is where you want to include more than two sites. That's where you need to connect 2 or 3, and ELAN is essentially more than 2 endpoints. So conclusion, MPLS is a layer 2.5 routing technique that leaves the packet intact and can be used with just about any networking standard out there. Typically, MPLS is purchased on top of an existing layer 2 service. Metro E is a modernized layer 2 service that is overtaking standards such as PPP, frame relay, ATM, SDH, SONET, etc. As a business manager, you should not be asking which one is better, but rather you should be asking which one is more appropriate for your business's needs. Metro E is popular where MPLS is necessary, or Metro E is popular where available, but MPLS is necessary between important locations where high-speed, secure connections are required. Thank you.